Well, hello, and thanks very much for the invitation. There's two French speakers in this room. One has spent most of his life with geneticians and Nobel Prize type scientists, and I've been running part of my research with truck drivers. So I'm going to try to make a link between physiology, which is my training, and my position in Bordeaux, and as you understand, real life. So the topic is quite wide, so we're going to try to combine data from human integrated physiology and epidemiology, and I'll try to cover three distinct patterns to answer or to try to answer to this question. The first one is a relationship between sleep deprivation, sleepiness, and performance. The second one is address the issue of vulnerability to sleep loss. And the third one is try to identify biomarkers that could help us, clinicians and scientists, to predict vulnerable people. So this is a very classical slide, which is still important to remain, and it's the relationship between sleep loss and sleep latency, okay, and other cognitive tasks. And if you see clearly, if you sleep deprive somebody, the best effect size you're going to have is about how fast he's going to sleep. Then the second one is going to be PVT, reaction time, okay, which is a very simple measure and very robust measure, which has a very direct translation on real life, which is, for instance, the reaction time on a driving simulator. Another way to look at it is that if you look somebody driving on a highway, you have to sustain a standard deviation, which is not crossing lines, okay? And if you increase your reaction time, the major risk or the major effect that you're going to see is what we call weaving, okay? And which is going to end up with crossing lines, okay? So this is an ecological measure that has been validated in many different trials. Another way to look at it is an experiment that we conducted here on a normal sleep-deprived subject at 4 a.m. And if you see the white lines, when the subject starts falling sleepy, just as you saw on the figure before, then it's going to start weaving. And as you notice, maybe a lot of cars now have systems that can pick up that weaving. And that weaving is a very sensitive biomarker of sleep loss that can be applied to very large numbers of people. This is interesting on the physiological level, but this is also interesting on the accidentological level, because you understand that if you are not able to track your weaving, then you end up in some catastrophic events that makes a lot of pertinence in public health and understanding of the consequences of sleep loss. So interestingly, scientists from the 90s to the 2000s have developed a lot of sophisticated protocols to try to make a link between self-perception of sleepiness, okay, and performance. And this is a very nice picture that I still quote, which is the relationship between 8 hours of sleep, 6 hours of sleep, 4 hours of sleep, and 3 consecutive nights of sleep deprivation. And you see there is a very nice linearity between acute sleep deprivation and chronic sleep deprivation at different level of pressure, okay? So no matter how you sleep deprive yourself, either on an acute mode or on a chronic mode, you're going to end up with losing performance in reaction time, okay? The very interesting point is that if you ask to the subject a very static and passive question, which is, how alert are you? It's not a question on performance, but simply, do you feel very alert? Do you feel alert? Do you feel neutral? Do you feel a bit sleepy, or do you feel very sleepy? When you get acute sleep deprivation, you get a very sensitive signal, a very nice biomarker, which follow perfectly performance. When you go into chronic sleep deprivation, there's a disconnection after the 4th day between the self-perception of sleepiness and the actual performance. So you see already that according to the time and the way you ask the questions, you're going to make a mismatch between what you expect in terms of performance and what does the subject is going to be able to feel. One hypothesis for this disconnection is that if you ask to somebody, how do you feel about your level of sleepiness, you're going to get a very, very wide range of questions. For instance, do you feel sleepy in front of the talk of Professor Philip? Yes, well, it's not really relevant. If you ask somebody, do you feel sleepy up to the point that you can't drive a car anymore and that you have either to stop or to end up having near misses, then you're going to face a much, much more severe problem. Imagine another way to say it is, if I ask you, are you sad? You can tell me yes. If I ask you, are you ready to attend suicide? If you say yes, that's a very different vision of the same symptom, okay? So this is a meta-analysis that we published 2 years ago where we look very, very specifically to a single question which asks, how hard is it to drive when you're sleepy, okay? And we did a meta-analysis on 15 studies, and what we show is that there's a global odd ratio, you see, of 2.5, and there's a consensus about the fact that if you refer to a very, very specific single symptoms about the difficulty to perform a performance, to sustain a performance, in the last year, there's a very high chance that you end up having an accident, okay? And except this very interesting study from China, who say that if you are extremely sleepy at the wheel, it's a protective factor against car accidents. Except that group, the 15 other studies say that up to a certain degree, it's a bad idea to drive when you're sleepy, okay? I give that take-home message. Take it, but trust me, it's a bad idea to drive when you're sleepy, okay? The other point that I want to show you is that you see there's two specific level of odd ratio. One here, it's around 1.5, 1.8, and this one goes up to 5, even 7 or 9, okay? That's probably highly related to how do we address the question about the handicap related to sleepiness, and that's a very, very important point. So going forward, that's an old study that we published, but that I still like to demonstrate how you can disconnect the relationship between sleep pressure and nocturnal performance and self-evaluation. And this is a specific group of subjects that we sustain awake for, you see, the whole night. And we were able to identify people who basically are extremely resistant to sleep loss and others who are very vulnerable, okay? Same age group, same condition, healthy subjects, no sleep problems. And so they are really, really very different. But when you look at how they express themselves on the Karolinska sleepiness scale, which is from 0 to 10, how do you feel sleepy? They'll build up the sleepiness in the same way. So there is some kind of disconnection, and probably the way your brain perceives sleepiness versus your brain perform under sleep deprivation is different. Now, from what I understand from the previous speakers, there's quite a big group about homeostasis here, but there are still also chronobiology, which is important in the way we look at performance. So this is a study where we basically looked at the relationship in the chronobiological rhythm and the circadian and the homeostatic component. And basically, we use a model of morning type and evening type subjects. And what we were able to show is that in these two populations, we have two circadian rhythms. When you dissect the chronobiological component from the homeostatic, they also differ through the homeostatic. So the message here is that your performance can be influenced or driven by the homeostatic drive, but the homeostatic drive himself can be influenced by chronobiology. Still, if you sleep deprived under constant routine, which is a very, very strict protocol, morning type and evening type subjects, it's quite striking to see that after exactly the same amount of time, which is about 17 hours, you start losing performance, okay? So no matter what is your chronotype, when you end up building up the pressure up to 17 hours, you break the performance. So that brings to another evidence, which is to say, how does your own physiology impact the relationship between your vulnerability to sleep loss? And this is a study that we have done also many years ago, but I still quote, which is the difference between young subjects and old subjects. And the interesting point is that you see the older one, when they are not sleep deprived, are not as fast as the young one. You can understand it if you look at the Olympics. Usually the one who run the 100 yards are in the 20s, and the one who run marathon are more in the 40s. So that confirms that. But the interesting point is that after X amount of hours of wake, Well, the youngs just get at the same level than the old ones. So in other words, and it's very contra-natural to what we believe, the other words is that people in their 50s are much, much more tolerant to sleep deprivation in terms of performance than the young one. What is even more striking, and which is interesting to predict accidents, because you know that the highest category of subjects involved in sleep-related accidents are young subjects, is a relationship between the perception of performance and the actual performance. And so this is a proportional decrement of performance, okay? So if you lose, if you're here, you lose little of your performance. If you're here, you lose a lot of your performance, okay? So as you understand, the young subjects were the one who lost the highest part of performance during sleep deprivation. But the interesting point is that the self-evaluation of performance or the self-evaluation of alertness was the same. So in other words, if you take an older subject, he's going to lose very little, but he's going to say, I'm highly impacted by sleepiness and sleep deprivation. And if you take a young subject, he's going to use a huge amount of performance, but he will rank himself at the same level. So that's also an interesting point to try to titrate exactly how can we trust the self-perception versus how the performance. So having said that, you clearly see now that there are heterogeneous patterns in humans regarding perception of sleepiness, but also vulnerability to sleep loss or to sleepiness. So the next step to try to dissect these principles are to look if there are markers that could explain that. And luckily, since 10 or 15 years, there have been tremendous amount of work to try to understand if there is a biological or genetic marker that could explain vulnerability to sleep loss. This is a very, very nice work from Hans-Peter Landolt that has been published in 2006, and the model is just great. For the one who are not aware, caffeine just blocks the adenosine receptors in the brain. In other words, it doesn't wake you up stimulating the alerting systems. Basically, what it does is that it blocks your homeostatic pressure, okay? And so what he did is a very elegant study protocol where he selected subjects who were sensitive to caffeine, in other words, subjects who have a lot of adenosine receptors, subjects who are insensitive to caffeine, so very little adenosine receptors, and he was able to demonstrate that only the sensitive subjects are vulnerable to sleep loss. In other words, the adenosine, which is the principal biomarker of homeostatic pressure, is also a biomarker of vulnerability to sleep loss. Okay? And this is related to ADORA genes, which is a gene which basically predicts how many adenosine receptors you're going to have in the cortex. Okay? So very, very nice demonstration on some genes can refer to a physiological mechanism that is going to predict if you are or not vulnerable to sleep loss. The second study, which was interesting, it's a little bit, we have to be a little bit cautious, but the way they presented it is very elegant, is a study from UK on a clock gene, period 3. And basically what they showed is that there is different alleles and polymorphisms, and the phenotype, the genotype PER355 differs from PER344 in the buildup of the homeostatic pressure. Okay, so you have a much higher homeostatic pressure if you are PER355, and you also have at the same time a much higher loss of performance when you're sleep deprived. And interestingly, there's no impact on the circadian. Okay, so second evidence to say that very probably through specific genotypes, the homeostatic drive is highly linked to the vulnerability to sleep loss. The third evidence from a study from the US, from Hans van Dongen, and this is a study on the Coma gene, which has also different alleles, and very nicely what they did is that they did a complicated task where you have to discriminate regarding response, so it's a bit like an inhibitory task. But what they show is that only the MET-MET allele is able to provide subjects who are going to resist to sleep deprivation. So in other words, the VAL allele is a marker of vulnerability to sleep loss. So we have here through 3 different genes, significant genetic biomarkers who could predict vulnerability to sleep loss. Okay, that's a similar study that has been published also very recently by Landolt, also on the COM gene, and basically they found about the same thing, that the subject MET basically do not increase the lapses when the VAL MET and the VAL significantly increase their performance loss. Okay, so that's kind of interesting because we have these biomarkers. Now the question is that if you go back to the clinic and if you're the physician, are you going to have to draw blood to the people to try to get a conclusion of their risk? And probably not. And one way to do it is to do classical MSLT scoring, which is a test which measures how fast you're going to sleep. And that study has linked the sleepiness score to the number of accidents in the last 10 years reported by the Department of Motor Vehicle Accidents. So you see here that there's a relationship between how fast you fall asleep and how much accidents you're going to face in the past 10 years. Another Italian study confirmed also the relationship of MSLT or MWT, which is the opposite, saying you have to stay awake instead of falling asleep. Okay, that gives also nice correlation between driving performance and sleepiness. And we have done a lot of studies in that dimension too, and we were able to demonstrate that at a specific level of sleepiness, specifically on the MWT, under 19 minutes, you have a significant increase of weaving and line crossing. Okay, so what we can say is that clinically we can use objective markers up to a certain limit to predict performance decrement. Okay. Now, the important point is if you use an MSLT or if you use an MWT, you need to have cut points and you have some kind of predictive values. So what we did, and this is an ongoing project, it's not published yet, but I just want to show it because we have a nice trend. Basically what we did is we selected cases where at least one near miss in the year or one reported accident in the year with a stable treatment, no change, okay? And these are narcoleptics, hypersomniacs, apneics, and we look at their sleep latency, okay? And then we put in front controls who had no accidents in the past years, okay? And we try to match them with age, sex, duration of driving, okay? And what we see is that we replicate a bit nicely the combination between what we have between the previous experimental studies and the accidental studies, which is if you are above 33 minutes, you're fine. Basically, if you fall asleep on the MWT after 33 minutes, which is a normal value, you see there's a very, very significant difference between case and controls in terms of accidents. If you go under in the gray limit between 19 and 33 minutes, things start getting more complicated, okay? And then if you go under 19, you see the situation reverse. In other words, the cases have more accident than the controls, okay? So that's the second message that you can take home, which is some objective measure of sleepiness can help predicting on a long-term period the actual ecological risk of being involved in an accident. Now, another way of addressing the problem is to go through treatment, okay? So we know that if you fall asleep, you have a risk of accidents. Now, how about if you introduce an alerting treatment and that you reverse sleepiness, how does this gonna impact on your performance, and how does that relate to your actual level of sleepiness? So that's what we published in 2014 on a specific population of narcoleptics and hypersomniacs, which are very, very sleepy. And we gave them basically modafinil, which is a reference drug about driving performance. And what we showed that, of course, the modafinil was able to improve alertness compared to the placebo. No news about that. But the second important point is that we showed that there was a relationship between the sleep latency and the mean number of inappropriate line crossing. Now, the interesting point is that if we had a very clear relationship, we would be very happy. But if you look at it in a more subtle way, you see that up there, there's a group of guys who are 40 minutes or 33, and basically they have no inappropriate line crossing, okay? So message is simple. You're awake, you drive well, fine. But what we want to know as clinicians is, how about if I'm sleepy? Am I going to be able to sustain some kind of performance, or am I going to lose it? And here, that's much, much more tricky. But you see, some people here have sleep latency of 20 minutes, and they still have very, very little inappropriate line crossing. In other words, if electroencephalographically you measure exactly the change between your status from alert to sleepy, which what does MWT, even that, if you challenge the subject on a 1 hour driving performance, the subject is still able to maintain performance. And there have been previous studies like the one of Mary Mittler in the New England Journal of Medicine who show that professional drivers were able to drive 20 minutes on a 10 hours driving trip in stage 1 with no accident. So there is a capacity either to sleep locally or to readapt or to integrate some cognitive information, probably in monotonous tasks, where you can sustain pretty well a performance. So that's a very important message, which makes life complicated, as you understand, because it would be nice if only the sleepy one would crash and only the awake one would stay awake, but there's a gray zone here, and maybe the alerting systems can help covering that, or the local sleep. Now, the last question that I want to address with you is a very specific clinical question for the patient who treats sleep apnea. There's been a huge debate for the people from UK. You know that there's been a law that has been applied, which is a bit complicated, which implies that you should refrain driving if you have an AHI above 15 or above 30. And so what we did is a study which is under review for publication, is that with Jean-Louis Pépin, we went through a French observatoire from the Federation of Ophthalmology, and we were able to collect 72,000 subjects who have been clinically evaluated and who had a polygraphy or polysomnography. So it's a big sample. And basically what we did out of them is that we selected subjects to whom we had questions. We had asked questions on how many near misses you had in the past years, how sleepy were you at the wheel, how frequently were feeling sleepiness at the wheel, okay? And basically the way we design or the way we analyze the study is we have here a control group, which is subjects who are not sleepy at all at the wheel and who have a negative AHI. First cut point is under 10, second cut point under 30. So for the one who are not familiar, if you are under 30, if you are above 30, you're supposed to have a massive sleep apnea syndrome, okay? So two different cut points. So here, no sleepiness, no AHI. Here, no sleepiness and positive AHI. Here, sleepy with no AHI. And here, sleepy and AHI, which is supposedly what we would expect to be a typical sleep apnea syndrome, okay, where people are very sleepy with a very high AHI. And then we look the relationship between the near misses and the sleep-related accidents. And we were very surprised by the results. As you see, if you look at the near misses here, okay, so for the one who are in the back and maybe who don't see these little figures, this is for an AHI cut point of 10. Under or above 10, and this is for an AHI above or superior to 30. If you have no sleepiness, no matter if you have an AHI positive or negative, okay, your risk of being involved in a near miss is very limited, okay? By the time you become sleepy, with or without sleepiness, there's a huge increase of risk of near misses, okay? Now, if you look to a more infrequent event, which is a real accident, these are the near misses and these are the accidents. If you look at the accidents, you get exactly the same pattern, okay? So now this is univariate relationship. So what we did is that we did a multiple regression analysis where we included the classical patterns of being involved in an accident, which is age, which is BMI, which is sex, profession, near misses, okay? The Epworth sleepiness scale, which is a very, very classical pattern used to evaluate sleepiness, okay? And finally, even if it was negative, we forced in the model AHI. And what you see is that very interestingly, the AHI does not remain in the model, okay? But the near misses are very, very highly predictive of accidents. And if you look at the Epworth sleepiness scale, you get significant but very low value. Okay. So what does that mean? That means that we have to weigh, we think, sleepiness versus performance. In other words, if you evaluate sleepiness as a static pattern, and I was very interested in the result from the UK Biobank and in the question you use about sleepiness, maybe you will have to reconsider the results that you got to try to get thresholds about what does mean the question that I do ask. But if you ask a very specific question about the risk, then you get very, very specific response. And we believe the model is okay because all the standard patterns about accidents like sex or age are integrated in the models. Okay? So after this rushing presentation, sorry, but we wanted to give some space for the discussion and for other speakers, I think we have several take-home message. The first ones, and luckily for us, sleepiness and or sleep loss clearly impact performance. There's no doubt about it. And I think that it's very important on a public health level to remind to the authorities that if you are sleepy at the wheel, that's a big problem. If somebody is sleepy at work during his scholar sleep, this is not a normal symptom, okay? And the way to qualify abnormality is probably the interaction with performance, either scholar performance or driving performance, okay? The second point, which makes things a little bit more complicated, is that there is not a unique marker to predict risk. In other words, that would be nice if we could say no more than 17 hours of wake, never less than 7 hours of sleep, but probably that's not true. Some people will be very okay with 6 hours. Some people will be very okay with 24 hours. We know that age is an important dimension for that. We know that there are some genetic biomarkers, but we need to adapt the message according to the specific pattern of the people. The third message is that homeostatic drive is probably a very, very important marker for degradation. So if we want to use drugs, or if we want to prevent accidents, or if we want to define solution, maybe we have to go through that dimension specifically for performance. Chronobiology might help too, but in more specific models like jet lag or things like that. And the important thing is that probably a combination between biomarkers plus genetic markers might help identifying people who have more risk. Then finally, on the clinical dimension, I think that it's relevant to consider that EEG is a significant marker to predict performance. It doesn't make a very linear relationship, but it does make a relationship, and it has the value of being objective, especially when you are in a clinical field where you can question about professional drivers that would ask about how do you feel. So I strongly advocate for the fact that we need to keep EEG in the field of sleep. And biomarkers will be interesting, but we need to combine biomarkers, sleep-wake changes, plus performance. Okay? And probably we have a lot to learn in the next years on ecological measure, because ecological measure are probably the ideal conditions, what we call in transport field operational trial, are the best condition where we're going to be able to select exactly who are the resistance and what are the adaptive behaviors. So probably we have biology, genetics, and behaviors, and these three interactions will be the best predictors of who can sustain and who cannot. And then finally, for our friend pneumologists, I think that we love sleep apnea, and we make a lot of money in our sleep clinics with sleep apnea, but sleep apnea should not be considered or quantified or qualified only on NHI. We need also to add a sleep dimension, especially in the evaluation of risk. Thank you very much.
Thank you very much, sir. Are there any questions?
Have you tried to work, I'm sure you have tried, to work with car manufacturers? Because it seems like an obvious thing would be to be able to measure this kind of swinging per person as a predictors of accident. And it seems like this is something that should automatically be almost measured for everyone, you know, more than your fuel consumption. I mean, that you actually know how much deviation you have. And
Yeah,
then you
yeah.
could...
We are part of the Open Lab Peugeot, which is an academic partnership with Peugeot, and we are designing the new car. So basically, when they started launching these automatic driving cars, we said we are dead. We have to do something else. So either we considered selling drugs, in addition to wine, things like that. But then we went into affective computing, which is a different story. But anyway.
You would make more money.
Yes, you're right. I still think about the drug story. Anyway, so they, very surprisingly, they came to see us because these autonomous vehicles are very tricky vehicles because you don't get any proactive cognitive biomarker from the drivers. In other words, the challenge that we have now is that subjects are seated in the car. They are no longer pushing the pedals or driving, and we have to capture what is the level of alertness, of what is the level of cognitive attention. So we, as you said, have access to some databases, and now for the one who bought new cars, there's buttons in cars where if you have an accident, you push the button, somebody is going to geolocalize you, and they track you, and they send the emergency teams immediately to where you are. Actually, these cars are transmitting data. I didn't know that. So they have 50,000 cars transmitting every day data on the weaving. And we start working on how does these patterns can be then extrapolated as markers. So yes, it's going to be a very interesting way of collecting data, and the idea we have would be to link that to biological markers and predictors. Yes.
So it's like the PSG is a race for the disappearance of the PSG versus a race of the disappearance of driving.
Exactly. That's exactly the same.
So I just wanted to ask about, you were talking about the sleep deprivation and the driving. Does it matter if you sleep deprive yourself acutely versus if it creeps up chronically? Because obviously a lot of our patients, if they've got AHI, then they may have started off with 1 or 2 awakenings, and then they get to a point where they've got more awakenings, but it happens over a period of years. Whereas some of the models that we're talking about for sleep deprivation, you start from day one shaking the test tubes or in whatever way. And I just don't know whether you can adapt to it based on some of the conversations earlier this morning.
It's a very good question, but we don't have, unfortunately, the answer. But what we know from the professional drivers is that there's a selection, there's a tremendous selection. For instance, in France, 60% of the drivers get out of their job in the first year. So in other words, professional drivers, and Marco Partinen presented 2 weeks ago in the French meeting, have an increasing ability to drive when they're sleepy. And I believe that they are genetically selected for that.
And that's similar to shift work when you
Yeah.
go talk to people.
And Marco shows something very interesting, which is he recorded them and followed them for 11 years. And he showed that these patients have a higher HI level after 11 years, but they decrease their MWT scores. So it's very, very interesting because in addition to dissociating the HI with the MWT, age goes in a favorable way. So probably regarding your question, I also would integrate the age. Meaning if somebody is 60, probably the relationship he's going to have with EHI versus sleepiness is going to be different from somebody who started the disease young. He will be more vulnerable if he's young. If he's 60 and he put like 30 kilos in 1 year and get a massive obstruction, maybe his risk will be lower than the same subject 30 years old.
Right. I'm a bit confused about the difference between what you call performance and the likelihood of just falling asleep. Because in my mind, they are not the same thing. They are two different things. So what is it that you're measuring exactly?
Alors, it's a good point, but my talk was very clinical. So you understand, if I ask you how bad is going to be your performance, probably you're going to say, what a stupid question from a Frenchman. If I ask you how bad are you likely to fall asleep now during the talk, you're going to be much better to answer. So in the real world, what we tend to ask to the patients is how do you behaviorally feel sleepy in front of a task, okay? So that's the reason why we use this symptom, okay? one of the discussion we had at lunch about precision medicine is that once we're going to have integrated biomarkers, which will have a direct follow-up of our performance versus our perception, that question will be useless. But since we don't have that now, we need to rely some kind of cognitive perception versus cognitive performance. So you're perfectly right. On one hand, you ask how sleepy you are. On the other hand, you want to know how good you are. But that's unfortunately what we do when we evaluate sleepy subjects.
Probably got time for one more question. It's short.
Thank you. It's more of a comment than a question. You were talking about the experienced drivers seem to not be affected by sleepiness in terms of their performance. We've seen something similar with commercial airline pilots, where we've had them enforced wakefulness for 24 hours, and various cognitive tests are impaired, but their flight performance in a simulator isn't. So I don't know if you had any further comment on that.
There's a very, very famous experiment which has been published only in a French review by a guy called Koblenz in the 70s. It's a great study. He had two simulators. One was a train simulator. So a train simulator is very stupid. You have a pedal, you drive the train, you have to push the pedal every like 30 seconds to keep the train going. Then he had a truck simulator where you have to drive the truck. He sleep deprived both population and they were doing good, both on the drivers. Then he shifted the simulators. In other words, he took the truck drivers in the train and he took the train drivers in the truck, and they all massively crashed. So there's really a behavioral selection, I believe. What you explained in the pilots should not drive their car going back home, probably. They should fly home. That's the message I would deliver. I hope I answered your question. Okay.
Thank you very much, Professor.
Merci.
Thank you very much, Professor Philippe.